Hey there, Mr. Chew and Bear Algebra here, wearing my smiley face tie and working some student challenge problems about solving systems of equations by elimination and multiplication. It's really important that you like my videos. Why? Because when you like them, the algorithm at YouTube pushes them out to more people. And I want more people to be able to see them. So please like my video if it helps you. If you have a question, comment, and I will answer all comments once I see them. I will answer them, and I check pretty much every day to see if I have new comments. There will be a button down here that you can subscribe. It's very important that you subscribe so that you can come into my videos as a subscriber and search my videos and maybe see the one I did the lesson before. And I post new videos every day. So let's get to it now. So challenge one, remember the challenge of these challenge problems is that you're going to have to multiply before you add or subtract. And there are 4 different ways to do it. I will just choose one way. You could do it another way, and if you get the same answer and checked it, it means you did it correct in another alternate way. There's usually 4 ways you can do them. Now, since I know that I can multiply a 3 by a -2 and then add down and get rid of my y, that's what I'm going to do. Otherwise, I'm going to have to multiply them both, and I don't want to make it any harder than what it is. So I'm going to take my top equation, multiply it by -2. So I've got to multiply the left by -2, and I've got to multiply the right by -2, because you have to multiply both sides by the same number to allow the equations to still be equal on both sides. And then I just rewrite the one that doesn't need changed. I always put lines underneath them so I know that I go to my next one. I do the distributive property, -4x plus -6y equals -5 times -2 is a +10. And now you should be able to see it looks like one of the simpler problems we were doing in an earlier video that'll be down in my playlist. I add down -4x plus 5x is x, and -6y plus 6y is 0, so x equals 2. So there's my value of 2. So now I'm going to substitute into either equation. So let's just do the top one. So 2x plus 3y equals -5, and x equals 2, so I substitute that in. Now I'm going to solve this. 2 times 2 is 4, plus 3y equals -5. I subtract a 4 from the left and the right using the subtraction property of equality. 4 minus 4 is 0, 0 plus 3y is 3y, and that equals -9. I divide both sides by 3. So y is going to equal -3. All right. So if y equals -3, I'm going to go ahead and check it over here, and then I'll erase the check just to make sure that I did do it right. So for y equals -3, I take my top equation and substitute -3 in to find x. So 2x. Now I already have my x. I already have 2 here. So I'm just verifying that that solution is the solution. So we're saying that the solution here is 2, -3. I would have just gotten my 2 again if I'd have kept going. So let's just verify now that it is true in both equations. So it's 2, -3. The 2 is my x, the 3 is my -y. So I substitute 2 times 2 plus 3 times -3 does that equal negative 5? 4 plus negative 9, does that equal negative 5? It sure does. And what does that mean? That just simply means that the point 2, negative 3 is on the graph of the top line. Now, the other line. I have my 5x plus 6y equals negative 8. So now I substitute a 2 for my x, a negative 3 for my y, 10 plus negative 18. Does that equal negative 8? Negative 8 equals negative 8, which means since it checks in both of them, if you graph this line and this line on the same grid, they will intersect at the point 2, negative 3. Okay. So now I'm going to erase the check. I'll leave everything else up here in case anyone's looking, still checking their work. You could always pause it. All right. So now, when I look at this, I look at my two lowest ones, and they're about the same, 4 and 2, 3 and 5. So it really doesn't matter. So I'm either going to multiply the top one by negative 2 and the bottom one by 4, or the top one by 2 and the bottom one by negative 4, add down, x goes away. Or you're going to multiply the top one by 5 and the bottom one by negative 3 and the y goes away. Or the top one by negative 5 and the bottom one by 3 and the y goes away. And it doesn't matter. So I'm just going to take and multiply the top one by 2. So I have to multiply both sides by 2, and the bottom one by negative 4. And again, it really doesn't matter which of the 4 options that I gave you. So I have to use a distributive property. So you got a 2 times 4x, which is 8x. 2 times plus 3y is plus 6y. And 1 times 2 is 2. And then the negative 4 times 2y is negative 8x. There we go. It's going to eliminate, which is what we want. Negative 4 times 5y is negative 20y. And 11 times 4 is negative 44. All right, now we're going to add them. Well, the 8x minus 8x is 0, which is what I want. 6y plus negative 20y is negative 14y equals negative 42. Now I divide both sides by negative 14. Negative 14 over negative 14 is 1. 1 times y is y. And negative 42 divided by negative 14 is positive 3. So now I have my y coordinate. So I'll say for y equals 3, I'm going to substitute in either one. It doesn't matter. So let's take the top one. Substitute. 3 times 3 is 9. Now I'm going to solve that 4x plus 9 equals 1. I subtract 9. So I have 4x equals negative 8. I divide the left by 4 and the right by 4 using the division property of equality. 4 over 4 is 1. 1 times x is x. Negative 8 divided by 4 is negative 2. So I believe the solution is negative 2, 3. Here's my x, here's my y. Now I'm going to substitute in either one. I'm just going to take the top one. 4x, because I need to do them both anyway. So it's 4 times negative 2 plus 3 times 3, does that equal 1? 4 times negative 2 is negative 8. 3 times 3 is 9. Is negative 8 plus 1 1? Sure is, because 1 is 1. What does that mean? That means that the point negative 2, 3 lies on the graph of this line. But I don't know if it lies on the graph of the second line. So I have to take my 2x plus my 5y, which is my second line, equals 11, and substitute it in. That's why in all of your earlier algebra work, you always need to be able to substitute to check it, because you have to do it here. My y is 3. I'm saying is at 11. Negative 4 plus 15. Does that equal 11? 11 equals 11. Double check. That means that if I graph both of these equations on the same coordinate grid, they will intersect at the point negative 2, 3. All right, I know it took some time, about 12 minutes just in this explanation, because these are harder problems. I'm Mr. Chu, this is Bear Algebra. There will be a link up here if you want to go back to the original lesson review. There'll be a playlist down here where you can see all the different ways, all the different videos I did on the different methods of solving systems if you're still struggling. Make sure you like this video and then subscribe to my YouTube channel. I'm Mr. Chu, and I want to help you learn the algebra. I'll see you next time, and you'll be able to try to check out what kind of a tie I'm going to wear in my next video.